Hello everybody and welcome to yet another math video. In this video, I will be covering the notes for assignment 20 in the course I teach ABS, and this will more broadly cover the simplex method. And in these first couple examples here, you can see example 2 down here, example 1. We just are taking the baby steps as far as the simplex method is concerned. We're going to set up a simplex tableau. We're going to find the first pivot and state the entering and exiting variables. Now, before you do all of that, you need to remember that first, we need to set up an E system here. So an E system just refers to an equations system, and you'll notice here that we have inequalities here. So remember, to do that, you just take each inequality and you can add a slack variable to the side with the other variables. So x sub 1 plus x sub 2 plus a slack variable 1 will now equal 20. Let's see, the second inequality, very similarly, 2x sub 1 plus 12x sub 2. Now, since this is a new equation and that this inequality represents a different slack variable, this will be slack 2 equals 60. And these non-negative constraints here, we do not need to include into the simplex tableau. So these are what constitute the E system. And one other thing that we have to do here is we have to make sure that we include the optimization equation or the objective function in the E system. Now, what's weird about this is you have to make sure that all of the variables are on one side. So normally we want P to be positive, so that means we'll subtract these terms to the left. And so the final equation here, 5x sub 1 minus 10x sub 2 plus p will equal 0. So these are the three equations we need for the E system. Next, we can actually set up the simplex tableau. And when you set up the simplex tableau, you'll want to remember that each column represents a variable in the equations we have in our E system. And there will be a final column over here without a title for these constants here on the right side of the equal sign. And each row represents the variables right now that are already solved for, and I'll explain what that means in a second. Here are all of the values for this particular tableau. And it's very simple to get these in the quote-unquote correct order. You see we label the slack 1, slack 2, and the last equation here, the objective function. They're always going to be in that order. So how do you write these equations in here like this? You find the equation that has slack variable 1, and then you fill in all of the coefficients. There's 1x1, 1x sub 2, 1s sub 1, no s sub 2's and no p's in this equation equals 20. Pretty easy. You can go through and do that with s sub 2. That's in this equation, so that'll go next. And then p, that only shows up in this equation up here, and that is last. So what is this s sub 1, s sub 2, p row labels for? Like the column labels are easy to see. How many x sub 1's are in each equation, so on, so on, so on. The s sub 1, s sub 2, and p are always going to be this way. And they are just telling you to look here. These direct us to a 1 in the matrix along the row. Stop here at s sub 1 because that's where the 1 is. That also has every other element in that column zeroed out. So if I went down to P here, I would go until I see a 1 that has zeros above and below it, if you can go above or below. So in this case, zeros are above. But S sub 2, there's the 1 in this row, and there are zeros above and below it. It's basically the matrix is solved, if you will, for these three variables in these three columns. All right, we have to move on to find the pivot next. In order to be successful with the simplex method, you have to be able to find the pivot. But before you find the pivot, you have to find the pivot column. The pivot column is very easily identifiable. If you look in the bottom row, or the row P here, where is the most negative number in this row? Well, it's this one here. It's a -10. And that tells you that the pivot column is right there. So from there, to find the pivot, the actual pivot position, we're not just looking for a column, we're looking for a specific number. Well, is it 1? Is it 12? Is it -10? We don't have any idea. But how you can figure that out is if you take the last element in each row, so for example, that would be 20 in the first row, and divide it by the number that's in the pivot column in that same row. So I would look at 20 divided by 1. Well, that's pretty easy, that's 20. But with the red row here, S sub 2 row, I've got a 60 divided by 12, and that equals 5. And then you're left with a couple new numbers and you scratch your head and you say, I don't know what to do next. Well, that's what I'm here for. The next step then is you would pick the smaller of these two values at the end. Well, you all know 5 is smaller than 20. So what that means then is that this is the pivot. That is where the pivot is. And I'm actually going to highlight it here. This is the pivot. It's 12. It's in the second column. It's in the second row. All right, so the last bit of information that you would need here then is the entering and exiting variables. So the entering variable is always going to be the one up here. Let's see if I can do this. There we go. Enter. And the exiting variable will be off to the left. S sub 2 would be exiting. And essentially what we would be doing here is we would be making this column look like this column. We want a 1 here and zeros above and below this. So we would have to use some row operations to make that happen, but for the time being, that's where we're going to leave this. This actual simplification will come in the next video. So let's move on to example 2 here. There we go. And I'm just going to run through the same process. You're not going to get tired of seeing it because this is exactly how the simplex method works. So first I'm going to create that E system. So again, with the inequalities down here, any of the non-negative constraints need to be written as equations by adding a slack variable. And every time you create a new equation, you need to increase the subscript on the slack variable by 1. So the first equation will have a slack sub 1. The second equation will have slack sub 2. And if you have more equations, you'll go slack sub 3, slack sub 4, and so on and so on. And again, with this optimization equation, this objective function up here, you want to make sure the p is positive. That's the only thing that is being asked of you here. So the second step, again, simplex tableau. And we always want to put the equation with S sub 1 first, the equation with S sub 2 second. And if you have other successive slack variables, then you want to put S sub 3 next and S sub 4 next and so on and so on. And you always want to end up with P, or the objective function, at the bottom. So we can get this all set up here to get that simplex tableau. That looks really nice. All right. So simplex tableau, very similarly done to the above example. We can take a look here. The pivot column will be here this time. Looks like. There we go. So again, to find the actual pivot here, you need to divide the last element by the element in the pivot column. So this would be 21 over 7, which is 3. This one here would be 28 over 14, which is 2. And then you'll pick the smaller number of those divisions and know that your pivot is right here. So from the pivot position, you can go straight up and you can see what the entering variable is, and you can go straight left and see what the exiting variable is. Now for the rest of this lesson, it's going to come in about 2 or 3 different videos, because in the successive videos, I will be going over the full simplex method all at once, so that you can get a taste for what that is and how it works. And I'll see you in the next video. Good luck, everybody.